Hey, how's it going? This is Mr. Hernandez, and I'm going over the comparing the normal curve Desmos activity. And so the very first slide here has a link, and you're basically taken to this. Um, and so when it's when you first get to it, it's like looks like this, where you don't really get to see the red normal curve. But as you move A forward and backwards, you can see the red curve appear, as well as the B. You can see it shifting. And so that's basically the two types of movements that normal a normal curve can change. And we describe this as a shift. It could even be like a horizontal shift, like if you were to do this with the parabola, it would shift left and shift right. And so in with the normal curve, it's called the mean, because the mean is this dotted line right down the middle. So right here at x equals 3, let's say, you have this dotted line right here down the middle of this red normal curve. And you know what, let me just make this a dotted line. And so you can see that there's this mean at 3. The mean is the line of symmetry, which is right down the middle. Mean is average. And then of course, if you look at the mean right here for the original normal curve, it's at 0. The mean is at 0. So when you look at the at this slider here, it changes the mean. And as the mean increases, the normal curve gets shifted to the right. And as the mean decreases, um, the curve gets shifted to the left. And and then the other thing is A. A is the standard deviation. And you can see the standard deviation as it goes up, it gets wider, and the top of the graph goes lower. And as the standard deviation decreases, you see that the graph, the normal curve gets squeezed in, and basically the peak of it is higher. So just to make things a little clearer, I just focus on is if it's squeezed in, the standard deviation is smaller, and if it's kind of stretched out, if it's wider, then the standard deviation is greater. So those are the types of movements that you have. And here you could see that these two normal curves here have the same standard deviation, because they are basically the same in terms of being wide or narrow. One is not more wide or narrower than the other. But the when I shift it to the right, the mean is greater on the red curve because it's more to the right. And here the mean is smaller. But then now here they have the same mean, but now the standard deviation is greater on the red one, which means it's wider. And they have the same mean, but here the standard deviation is less on the red. The red one has a smaller standard deviation, which means that it's getting squeezed in. It's more narrow. And so when you look at this here, these sketches, you would basically and these are all anonymous names. These are fake names. But what we should see here is it if the mean is smaller and the standard deviation is the same, well, that means that this mean is smaller. The standard deviation. So let's make the standard deviation the same. So they should be so that these have the same standard deviation. And if the mean is smaller, that means that this gets shifted to the left. Anywhere over here is smaller. The mean is smaller because here on this black normal curve, the mean is 0, but on this red normal curve, the mean is -2. So the mean is smaller here. So if you do want a smaller mean, then you should draw this normal curve to the left. So all these graphs to the left are correct. It should basically be the best you can to make it an exact copy of this original one, but shifted to the left. So this one's correct. This one should be more to the left, and it should have the same, it should go up just as high because the standard deviation hasn't changed. This one, the standard deviation, looks like it got lower, the standard deviation, since it got wider. But in this case, it's supposed to be the same. So it should be the exact copy of this, except shifted to the left. So these two are kind of like needing to be adjusted here. This one's correct here, shifted to the left, same exact wideness. This one's a good one, shifted to the left, the same wideness as this one. Let's look at this one. This has the same mean and the standard deviation is smaller. So um, if the standard deviation is smaller, it'll be squeezed in. And if the mean is the same, then it'll basically have the same line of symmetry. They'll both be lined up right at zero. So it could look like that, or maybe even less. Should be a little bit squeezed in and going up a little bit higher with um, a smaller standard deviation. So this one is good. This one is good. This one is good. This is a lower standard deviation, so this one needs to be adjusted. This one's a little bit higher. Yeah, that's good. This one's a little bit higher. That's good. So there should be no shifting because the mean is the same, right? So they all should be right at the middle. This is a good one. Yep, this is a good one too. It's a little bit higher. Okay, so what else? Larger mean, standard deviation the same. So that means it's shifted to the right, right? So larger mean. So if the standard deviation is the same, it's the same wideness, narrowness. But if the mean is increased, well, that's not the mean. This is the mean. If the mean is increased, then it's going to be shifted to the right. So larger mean shifted to the right. So this is a good one. This is a good one here. This is a good one. This looks like they were thinking about the standard deviation, which makes it wider or narrower, but that's not what this is saying. The standard deviation here is the same, so it wouldn't be more wider, narrower, but it should be shifted to the right, like this one. Maybe this, maximum here is a little bit too high. It should be the same as that one. This is a good one. This is good too. This one, it looks like they changed the standard deviation to make it lower standard deviation, which makes it wider. But remember, the standard deviation stays the same. So larger mean means just shift it to the right. These two are good. Okay, last one. So smaller mean, larger standard deviation. So smaller mean means shifted to the left, and larger standard deviation means made wider. So it could look like this. And yeah, this is a good one. So smaller mean shifted to the left. So these two should be shifted to the left, and this one as well. This is shifted to the left, and it looks like it is wider too because the standard deviation is larger. This is shifted to the right, but that would mean that it would be a greater mean. But here it's asking for a smaller mean, so it actually should shift to the left. Um, this is good right here. Yep. This is okay, but this is shifted to the left, but because the standard deviation is larger, it should go wider than the original. So I think this one might be a little bit wider, but remember, as you go wider, the top of it has to go lower, kind of like this. And so yeah, these are. This one looks like it's shifted to the right, which means gotta adjust that. But this one has a standard deviation that's wider, so that's good because the standard deviation is larger, which means there's a larger spread. It's spread out more. Okay, but so this one just needs to shift to the left. This one looks like it's totally the opposite. So smaller mean shifted to the left, so move it over here. Standard deviation larger, it should get wider, not narrower like this one. So it should be wider out here. And again, when you make it wider, the maximum should go lower. Okay, well, that's all the feedback I have now. And so go ahead and complete the reflection question.